Alright everyone, now let's quickly write the C++ implementation of the quick sorting algorithm based on the steps that we have discussed in the previous videos. So here I have defined a new class and I have added the function for implementing the quick sorting as well. If you remember the quick sorting algorithm pseudocode that we have discussed, right, what I mentioned, we will be solving it in a recursive way. So as part of the recursive way, what we will do, we will try to identify a pivot index for a particular element, and we will make sure that the further recursive calls are happening between starting index and ending index based on the pivot that we get, right? So to support that recursive implementation along with the array that we take, what I will do is I will take the start index and end index as well as part of the main function declaration. So those two values also I have taken. Since we are going to implement it in a recursive way, we need to have a base condition where we can stop the further recursive calls, right? Where we stop the further recursive calls whenever this start is greater than or equal to end. That basically represents that we have gone till array that has only one value and there is no further division possible based on the pivot. So here at any given point of time when the start is greater than or equal to end, we have completed the sorting and we can directly return the array that we have gotten, which is nothing but vector of integers here. If this is not the case, then what we need to do, we need to calculate the pivot index, and based on that pivot index we will divide the further recursive calls into two further a function calls. So let's just assume that we will write one function called get pivot index. In couple of minutes we will write this. Let's just store whatever the pivot that we are going to get inside this pivot variable. Now this get pivot index, right, what it does, it will take the all array of values that we have gotten and it will take the start index and end index that we are getting as well. Okay, why? We need to find the appropriate value that we pick for the value that is at start index in the start to end range only, because once we find the pivot index is nothing but the perfect position for a value, right? All the left side values will be smaller than the whatever the value we have at the pivot index, and all the values on the right side of it will be greater than the pivot index. But that doesn't mean that they are necessarily sorted. I mean left part and right part are necessarily sorted. But whatever the value we have at the pivot index, it is the perfect position for that particular value. That is the reason why to find the particular position in the start till end, I am going to pass the start index and end index as well. Okay, so this, let's just call it this way. And once we get this, right, what we will do, we will call the recursive call this.quicksort. We will pass all the array of values, but from whatever the start that we have gotten till pivot -1, we need to sort them. That is the reason why for the left part of the array, start I will pass and end will be pivot -1. Similarly for the right part of the array, what we will do, this.quicksort of whatever the array that we have gotten, and for the right part the starting index would be whatever the pivot that we have gotten, pivot +1, and whatever the end that we have gotten. Once this is done, what we can do, return the array that we have gotten itself. Okay, so this is the quick sorting implementation. Now we still have this get pivot index implementation pending. So what we will do, let's just write the function for that. So here let me just copy the same function signature and paste it here, and later let me just go ahead and modify the function name to get pivot index. Okay, now what we will do, in the beginning we will assume that the value that is at this start index, we need to move it to the perfect position. So let's just call the pivot that we want is nothing but whatever the array of value we have at the start. Similarly, in the beginning, what we will assume, whatever the pivot index that we want, we will assume whatever the start that we have gotten itself. See, the start index that we have gotten, I am assuming it itself is a pivot index, and whatever the value we have at the start index from the array, that I am assuming is pivot. So this pivot, we need to move it to the perfect pivot index and we need to return in the end. Now what we need to do, we need to iterate from start we have picked. From start plus 1 till end we need to search and we need to make sure that we are moving this pivot to its perfect position, making sure on the right side all the values are greater and on the left side all the values are smaller. So for that, what I will do is for int, let me just run a loop from start plus 1 and I will run till I less than or equal to end I plus plus, and in each and every step what I will do is, if at all the value we have, the pivot value we have, which is pivot, is greater than whatever the value we have at this ith index. Now observe this, whatever the value we have at this pivot is greater than whatever the value we have at array of I. That means the value we have at ith index is smaller. That means it should come on the left side. That is the reason why what I will do is, whatever the pivot index that we have, we will simply increment it by 1 and then we will swap the value at ith index and the value we have at the pivot index. So for that, for swapping, let me just define a variable called temp and let me just read the value we have at the ith index. Once we have this array of I, what we'll do, array of I is equal to array of pivot index, whatever the value we have at the pivot index, and once we are done with this, array of pivot index is equal to whatever the value we have at the temp variable. Okay, so this logic will keep on going as long as this condition matches. Once this is done, right, the perfect position for the value we have at the start index is nothing but this pivot index. So all we have to do is swap the value that we have at start with the value we have at the pivot index. So let me just read that value again here. Int temp is equal to whatever the value we have at the start index. After that, array of pivot index is equal to array of start equal to array of, we need to swap, right? So array of pivot index, and after that array of pivot index equal to whatever the value we had at the start, which is present inside the temporary variable. Now this made sure that we are moving the value we have at the start index to perfect position, making sure that all the greater values will be on the right, all the smaller values will be on the left. So in the end, we need to return the pivot index. So let's return the pivot index. Okay, so this is the pivot logic. We have specifically discussed the algorithm and pseudocode and everything, but we have not written the implementation because I wanted to implement here. So as part of this function, we just want to return the index, right? So the return type will be integer. Okay, so that I have written. Okay, so that basically completes the get pivot index implementation as well. I just want to make sure couple of things. Till end we are reading this. Okay, so this is perfectly fine, this is perfectly fine, and this looks good. Now to call this quick sorting function that we have implemented, I have written some sorting function call implementation similar to how we have executed and validated in the previous sorting algorithms. So here I have taken the array, and along with that, what we want to do, we need to pass the start index for this quick sorting, right? That start index is nothing but 0 and end index is nothing but whatever the array that we have gotten dot size minus 1. Okay, so this is the valid end index. So if at all, if you want, you can execute this for various scenarios and validate it, and it will perfectly work fine. Okay, if at all, if you want, you can execute this and validate the same as well, covering various scenarios with different types of input. Okay, anyway, that's the quick sorting implementation in C++. Okay, thanks for watching. I'll see you in the next one.